Hey everybody, welcome to Volumes of Revolution. This is Nicholas, JMV, and today we're going to be talking about revolving around lines, and we're going to be using the washer method. So just a reminder here that we have two formulas that we use. When we're revolving around like the x-axis or a horizontal line, we're looking at the volume is equal to pi times the integral from a to b of big R of x squared minus little r of x squared, and we're integrating with respect to x. Big R squared is the longer radius, the longer length, and R is going to be the smaller. So this is considered outer radius and inner radius. Same thing if we rotate around the y-axis or a vertical line. We just have our function a little bit different, our integral, pi times the integral from c to d of r of y squared minus r of y, little r of y squared, outer radius, inner radius. And so these are the two formulas we're primarily going to be using. So when we take volumes, we've already done a couple of examples, okay? You really want to draw the figures. So I have the figures drawn in each of these. Okay, so let's go ahead and calculate the volume V obtained by revolving the region between y equals x squared, that's my blue graph here, and y equals x, that kind of powdered blue straight line there, about the line y equals 2. Now that is the vertical line, or excuse me, horizontal line that's marked in red here. So the first thing you want to do is try to find big R of x and little r of x. Now, I'm going to be rotating vertically around a line, around a horizontal line. So I know that I'm going to draw my line from what I'm revolving around, this line y equals 2. I'm going to draw a line all the way down to the furthest function. Now that furthest function is x squared. That is big R. Okay, little r is going to be if I draw a line from the same line I'm revolving around to the first function I get to. It's a shorter distance, a shorter radius. Okay, that's little r. Okay, so now that I have big R and little r, okay, I can go ahead and write them. So I'm going to go ahead and write them down here. So big R of x, and if I think about how do I find the length of this line? So like the distance between two functions, the area between functions, right? To get the length of this line, it's going to be the top function minus the bottom function. Well, my top function is 2. So this is going to be 2 minus the bottom function with big R is x squared. So that's big R of x right there. Little r of x is going to be the top function minus the bottom function to get that length, which is right here. So that's going to be 2 minus x. So now I'm ready to go ahead and set up my volume. Okay, so the volume is going to be equal to pi times my lower and upper limit of integration. Well, it's going to be where they intersect, right here and right here, so from 0 to 1. So I'm going to go from 0 to 1. Big R of x is 2 minus x squared. That's going to be squared minus little r of x, which is 2 minus x, and that's going to be squared, and that's all with respect to dx. Now, if you have a graphing calculator, you could go ahead and plug this in. You would hit math 9. Okay, now I got to multiply all this by pi. I'm going to go from 0 to 1, and now this is the newer operating system, and I could do parentheses 2 minus x squared. Okay, close it off, squared, minus 2 minus x, close it off, squared, and that's with respect to x. I haven't multiplied by pi yet, so I could do times pi, and there's my actual area, 1.67676. But if I was going to do that by hand, and let me show you how to do that by hand. Okay, so it takes a little bit. So I'm going to do pi times from 0 to 1. Now I have to expand that out. So when I expand 2 minus x squared out, I get x to the 4th minus 4x squared plus 4. And then I'm going to subtract off 2 minus x squared, that expanded is x squared minus 4x plus 4. And that's all with respect to dx. Now I'm going to combine like terms. So now I have pi from 0 to 1 integrating. I'm going to end up with, I get x to the 4th minus 5x squared plus 4x when I combine my like terms, and that's with respect to dx. Now I can integrate that. So I go ahead and I integrate. So I got pi times, that's x to the 5th over 5 minus 5 over 3 x cubed plus 2x squared. Okay, that's going from 0 to 1. Now I don't have to plug 0 in because that's just going to be 0. Okay, so now what I can do here is I can go ahead and integrate or plug in my values, and I get pi times 1/5 minus 5/3 plus 2. Okay, and I can simplify that even further, and I could say, well, if I want exact, 15 looks like the common, so it's 3/15 minus 25/15 plus 30/15. Okay, so that gives me 8/15 pi. Okay, so that's the exact answer, and that ends up being 1.676. Okay, so that's on my first example. We're going to go ahead and stop this video because it's about 6 minutes, and we'll go ahead and give you a couple other videos. So if you have any questions or comments, you can write them below. We'll see you for the next video.